Hello everyone. Myself, Suresh D, Assistant Professor from the Department of Electronics and Communication Engineering, St. Joseph Institute of Technology. Today we are going to discuss in this session about digital and digital electronics and code conversions. So this is a basic topic for in the engineering field, and all the students should know about what is digital and digital electronics and what is code conversions, because it's a main role of in this. Yeah, we all know that we have a two different signal. One is analog and another one is digital signal. Analog is continuous time varying signal. If you want to convey the informations of any type of text or audio or video, whatever it is, in terms of continuous time varying signal, is called as an analog information. And for digital is a representation of digits instead of continuous time varying signal, continuous signal. So in forms of binary representation, zeros and ones. Okay, where they are using digital in general. Uh, Smartphones, computers, everywhere the digital representation is to be highlighted. The reason is, compared to analog, the digital is very crucial, and we have a good accuracy and highest bandwidth. So more data transmissions they are using for processing or data transmission, anything, digital is preferable one. Okay, so I just want to discuss about code conversion right now, because we have in a short time, we just discuss about code conversions. So generally, code conversion is mean that it is a converting of one form of signal into another. That means conversion is one form of into another form. Code conversion is one form of code into another form of code without changing of original information. So this is the meaning of code conversion, right? Okay. So what are the types? How many types of code conversions are available? So generally, it's based on the number systems. We have four different number system. One is binary, then octal, and decimal, and hexadecimal. So four different number systems are available. So we just want to convert binary into another forms and another form into back to binary likewise. Okay, so what we are going to discuss in this session is, we have different types of code conversions are available. In the code conversions, the first one, basic type, and everybody is learning about it and used in the many applications: binary to gray and gray to binary. Then binary to hexa and hexa to binary, decimal to other system conversions, other system to so many things are there. In that code conversions, preferably binary to gray, binary to BCD, binary to XS3, binary to hexadecimal. So many things are there. In the session, we are going to discuss and deeply about binary to gray. Okay, so hopeful this session will help you easiest way to remembering the information, and it's useful for your exam point of view, as well as basically how the number systems and code conversions will be happened. Not only for that digital electronics, this for computer organizations, microprocessor, any related to the embedded. So this is a prerequisite on this. Okay, yeah, well, listen, right? So binary to gray. Okay, so before going to binary, what thing is actually first, everybody should know about what is binary. So I already told that binary representations, zeros and ones. So zero is a low and one is high, or in terms as off and this will be on. So based on the information, we just convey only in the two order, zeros and ones. And gray will be the representations of the one of the code conversions, type of coding. And this code will be framed with the help of some set of procedures, like we just keep as an gray as the same, and that will be two as a modular additions. Generally we call it as an XR operation. So gray code will be make it with the help of XR operations. Okay, right, fine. Okay, so before that, everybody know the conversion format. What is the binary codes, and the code will have different types. In the different types, one of the type will be weighted binary code. Okay, so we don't want to go in depth in the binary code session, But in that, if you need, we'll look on in the other videos, right? So binary code, non-weighted code, weighted code will be there. In among that, a weighted code, we are taking an example that will the basic of this one. So we have different types of weighted code. That means positionally weighted is called as a weighted code. So in that 8421, 2421, 5421, multiple things are there, right? In that basically we are taken as 8421. This is a code we are usually represented. 8421 is mean that this is positionally weighted. The first bit position will be 1 and this will be 2 and this will be 4 and 8. So maximum of summation of the score will be 15, and that is the meaning of 0 to 16. So 0 to 15 with the out of 16, right? So this is the helpful we are going to use it. So binary representation and gray. So we all know that 0, 1, 2 up to the representation of decimal number 9, and afterwards A, B, C up to F. So this is a representation of 15 and this is a representation of 0, right? So here what we are going to do is binaries and zeros and ones. We are going to use hexadecimal number as a binary number here, and equivalent decimal number converted into binary, and how the binary number will convert into a gray code, right? So I just making the tabulation, so it's easier for you to understandable how many. It's mean that characteristics tables we can say that, truth table we can say that, anything, but it is the meaning of relationship between two codes, right? So conversions, how we are going to convert. So here I'm writing as binary and this will be gray, right? So binary since 8421, so 4 will be taken, and I just start with the first will be lowest B0, and the next one will be B1, and this will be B2, and finally B3. So this is the first LSB portion, and the next immediate MSB, next immediate MSB, and final MSB will be, right? And for gray code, the same way I just write it, the LSB, MSB, next MSB, and the most MSB, right? So this is a 4 code. So totally what it happened is the basic combination. So yeah, everybody know that 2 power n is a formula for finding the more number of combination, right? 2 power n. So if n is equal to 4, so 2 power 4, totally 16 combinations will come. So how the combinations, everybody know that we substitute zeros and ones in the 8421 positionally, and some of the values will make it in the equal value, that is the equivalent decimal number, and followed by the hexadecimal number. So what I'm going to write it, first 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and followed by 10 is the equivalent of A, B, C, D, E, and F, right? So this is the thing. So I just want to write 0. I just substitute as, for example, 8421. So if I'm putting 0 for all the positions, the summation of value will be multiplied with the weighting value. So totally is equal to 0, right? So I hope you not clear in that. So you just substitute 8421 in the positionally, each and every position, what value if you have substituted, that should be multiplied of the position value and your digital value, that summation is equivalent to this value. So if I'm putting 0, 0 into 1, 0, 0 into 2, 0, 0 into 4, 0, 0 into 8, so summation of all zeros is equal to 0. This is a representation of binary. So everybody know that. Likewise, I'm putting 1 here and remaining 0. So summation of all this is equivalent to 1, and followed by this is 1, and this is 2, and if I'm going to 3, 1 into 2 plus 1 into 1, 3, so remaining will be 0, followed by here 1 and 0, 0, 0, and followed by 4, 5, 0, 0, and 4, 2, 6, 0, 0, and 4, 6, 7, so summation of value is 7, and up to this one part I just for our convenient. If you want, you can make into 4, 4, 4, it's easier. Otherwise, if you are going to write in a sum of terms, will be maybe mistake will happen, right? So up to the 7 and 8, so I'm starting with here 0, 0, 0. It means that 1 into 8 plus 0 into 4 plus 0 into 2, 0 into 1. So finally is equal to 8 plus 0 plus 0 plus 0 is equal to 8, right? Then 8 plus 1, 9. So totally 9. 8 plus 2 is equal to 10. In hexadecimal, it is A. and 8 plus 2 plus 1, it's equivalent of 11, and 8 plus 4, 12, so remaining will be 0. So up to this I just make for our understanding purpose, not for anything else. And 8, 4 and 1, so 12 plus 1, 13, 8 plus 4 plus 2, 14, and 8 plus 4 plus 2 plus 1, so finally it is the equivalent of what? 15. So we are representing the binary number 0 to 15, so starting from 0 and ending with 15, because the reason is 2 power n, 4 input combination, totally 15, the maximum value will be 15, total combination will be 16, right? Okay, so what we actually doing here, so we know that okay. So what we doing is we just make conversions each and every bit. So every G will be called it as a gray. So each and every gray will be consideration of the procedures to convert binary to gray. Okay, what is the step? Here I just write the steps. The first step will be, okay, how to convert G3, G2, G1, G1 not. G3 will be as it is. What is the MSB in binary? The first step will be MSB of first binary is equivalent to MSB of gray MSB. That means first MSB B3, right, is equivalent to G3. So MSB of this G3 will be same as it is this one. So it's a common one. So what we can do it, we can directly copy all the B3 into G3 directly. That's the first. That means most significant of the binary bit is same as it is in the gray of the first bit. That is the MSB. This and this will be I am representing. Okay. The step number 2 is what we are going to tell us the second bit. That means MSB of binary, that is B3, XOR addition with next immediate or neighbor bit, that means B2. Okay, do XOR operation of B3 with next immediate neighbor bit. So that is a bit of G2. Okay, hope you understand. First will be same as it is. Second will be the first MSB and followed by next neighbor bit should be XOR operation. That answer comes into G2. Then third step, right? Next immediate, that means that B2. B2 is the now highest bit. The B2 XOR of next immediate bit, that is B1, that will be equivalent of G1. Okay. So likewise for the next also, the fourth step will be B1, alright, exclusive of B0, the result will be G0. So this is a procedure. So now you can understand the same information, but we did not change it, but we have a procedure. The first will be same, second followed by everything will be XOR operation of the next immediate neighbor bit. So we can get G3, G2, G1, G0. This wise we are going to fill the boxes, and once it's converted, you just make that primary number, that is min terms, to be find out and make it in the K-map and find the logic diagram also. Okay. So what we are doing is how to convert binary to gray. So I am giving the proof, explanations and steps for 116, that is 6 combination 4-bit binary to gray, not in the single value. The total period will be showing you, right? So here what I'm trying to say is, we just start before that. I'm telling that repeatedly, XOR gate, XOR gate, XOR gate. What is XOR gate? So I have an A, B, 2 input, A exclusive of B. This is a truth table for exclusive of. Exclusive and mod will be same. So if you have 2 input, so 2 different combinations 0, 0, 0, 1, 1, 0, 1, 1. What actually meaning is, this A exclusive B is the meaning of A bar B plus A B bar. That means one should be complement, another should be uncomplement. Some of the both combination will be take it as an XOR. So if I'm substitute 0, 0 in all the cases, what it happen is, it comes as 0. If you want to check, you can check it. This is 0 and bar will be make it as 1, 0, 1 into 0, 0. Again this is 0 and this is 1, 1 and 0. So totally the value will be 0, right? So simple thing is what actually XOR gate is a special gate. If both inputs are same, what it will come as 0. If any one of the input is different, the output comes as 1. So it's the easiest way, and remember it. If different input arise, output will be 1. If same input will be there, output will be 0. Okay, right. If you are taken this based on this kind. So what is the first case? The 0. I just keep same as MSB as M. Do XOR of this. Both are same. Result will be 0. Both are same. Result will be 0. Both are same. Result will be 0. Right? This is the first. Second, I'm taking this MSB as it is. 0 exclusive of 0, 0. 0 exclusive of 0. 0 exclusive of 0, 1. So there is no changes of binary for 1. And second, 0 MSB. Do this case 0. Do this case 1. And for this one, 1. So this will be differ, right? Now you understood. Some changes will be happen. Not for all the combination, but it will be happen. Okay, fine. Compared to that, next third will be 0, 0 with 0, 0, 0 with 1, 1, 1 with 1, 0, right? Then 0, 0 with 1, 1, 1 with 0, 1, 0 with 0, 0. Hope you follow it and you just fill it. Okay. And finally, you can check and cross verify what I have written. This is 0, 0 with 1, 1, 1 with 0, 1, 0 with 1, 1, right? And next one, 0, 0 with 1, 1, 1 with 1, 0, 1 with 0, 1, 0 with 1. First should be 0, right? And followed by 0 with 1, 1, 1, 1 will be 0, 1, 1 will be 0, right? Hope you understand and you are following and completed, right? Next one, as it is MSB, 1 will 1, 0, 1 will 1, 1, 1 combined with the 0, and this will be same and this will be same. Then 1, same, so 0, different will 1, same will 0. 1, 1, again 1 and 1. For this combination, all comes as a 1, right? And next will be 1, 1, 0 will be 1, 0, 1 will be 1, 1, 1 will be 0, right? And this combination 1, 1, 1, 0, 0, 1, 1, 0, 0, 0. And next combination 1, 1, 1, 0, 1, 0, 1, 0, 1, 1. And 1, 1, 1, 0, 1, 1, 0, 1, 0 will be 1. And the last will be 1, 0, 0, 0. Just look at it. No repeated conversions will be happened, right? As it is, what we trying to say that the same will comes to you, but the procedures, if binary equivalent is 0, gray is 0. Binary equivalent 1, gray will 1. Binary equivalent 2, gray will be 3. That will be the changes, right? And for example, B. B is the meaning of 11. Here 11. What is the combination? 8 plus 4 plus 2, 14. So that is a different. Okay. So this is a binary to gray. If you want to learn clearly, so I'm taking one of the example 1, 0, 0, 1, 0. If I'm moving to the 5-bit, this is a binary representation. What is the equivalent gray? So you all know that MSB will be same and MS next to be is 1. Do XOR of this one 0. Do XOR of this one 1. Do XOR of this one 1. So this is a gray code, right? So any numbers 3-bit, 4-bit, 5-bit, whatever up to 2 power n, this is a procedure to convert it. Okay. Suppose they are asking to draw a circuit. Okay. Draw a circuit for the binary to gray. So how you are going to do it? So first step should be take it as a min terms, sum of product min terms. So totally how many inputs are there? Totally B3, B2, B1 and B0. Okay. So for the summation of M is the representation of min terms, summation of M. What is the value? What is the value for this? Wherever 1 present in this. For example, G3 if I am going to find it. Where 1 is present. Okay. What is the equivalent number for this one? You just write it. So here this is 1, 1, 1, 1. So 8, 9, 10, 11, 12, 13, 14 and 15. Okay. Then come to the G2. What is G2? Where 1 is present? 1, 1, 1, 1. That means 4, 5. F of B3, B2, B1 and B0. Okay. So summation of M 4, 5, 6, 7, and followed by where it is 8, correct? 4 5 6 7 8, and that means A will be as 10 and this will be 11. Okay, where it will be 1 1 1 1 1 1, right? So you just take notice. Okay, so this will be what combination will comes to you, so you just fill it in. Okay, right? So come to the next one. Similarly G1 and similarly G0. So if you're going to take it each and every value, you can get like this. So from this I just want to put one of the circuit, right? So if I'm written as J3, how to put it? So 4 combination, so 4 variable came up, you have to take it, right? 4 variable came up. So 4 variable came up. So 2 combination B3, B2, and here B1, B0. Likewise 0 0 0 1 1 1 1 0 0 0 0 1 1 1 1 0. If you are going to fill it, 0 position, 1 position, 2 position, 3 4 5 6 7, and this is 8 9 10 11 12 13 and 14 and 15, right? So how you are going to fill it? So what are the number present over here? 8, 9, 10, 11, 12, 13, 14, 15. How we are going to group it? So maximum number will be 16. If 16, all 16 will present, you just make it as a 1 and finally will be 1. But here we have a maximum number 8 and this will be adjacent rows. So just make it as in a group. So this is B3 bar, B3 B2 and B3 bar B2, right? Same wise B1 B0, B1 B0 bar. Okay, so all will be row will be there, so that is equivalent to 1, and here the combined case what it actually is, right? So you just taken on it, that particular number will be comes to this cases, right? So what we are trying to say is, so here this case will be 0 0 0 1 1 1 1 0. So B3 bar B2 bar B3 bar B2 B3 B2, and this is B3 B2 bar. So here common term is B3. Okay, common term is B3. So G3 is equal to B3. What actually we done in the truth table? The same will comes to us, right? The same to come to us. So okay, so likewise next G2 will be do the same for the truth table characteristic came up and followed by the equations and like that. So after that G1 and after that G0. So each and every category will be do the same procedure, and based on that you should convert one binary number into gray number. Finally you can get an equations. If you want to do that, we can do, no problem at all. We have time, but the practice from your side is easiest. Otherwise if you're copying what I am written over here, this will not help you, because when you're looking the board, when I'm explaining it, that will be looking very easier. But when you are taking as a practice, for this one, you may be as in a small mistake. Instead of this one, you just written here as in a 1, here maybe 0. Completely this will be wrong. So small or minor changes will make very severe result. So just do practice better and get in a binary to gray. So we have in a small time. In that time, we just take for the gray to binary. Okay, gray to binary. So that will help you. So uh, we just seeing before us binary to gray, now gray to binary. So what is the procedure for this one is the same as it is 4-bit. So G3, G2, G1, G0, and B3, B2, B1, and B0, right? So there is no changes in that, only just swapped it. But what actual is, when binary we have an order 0 to 15. But for gray code, there is no order in that, because previously we have discussed 0, 1, then suddenly move to the 3 and come back to 2 and 5, 11, 12. There is no order. So we are not supposed to write it here. So what we have best practice is, we just written as same as binary order, but consider that is a gray code. So here it will conversion will be happen. Okay. So I just again back to 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0 1 double 0, 0 1 0 1, 0 1 1 0, and 0 triple 1. So up to 8, and followed by 1 triple 0, 1 0 0 1, 1 0 1 0, 1 0 1 1, 1 1 10, and 11, 12, and 13, 14, and 15. Right? The same what we previously done, the same thing will be there, right? Okay, how we are going to convert? The same XOR gate will use for that, but the difference is, in previous cases, first bit, that means G3, G3 is B3, right? And G2 is XOR of B2, B1, the result will be, okay? And XOR of B1, B2, result will be G1, and B0 is a G naught XOR of this two, the result will be like this. Okay, but here the process will be completely different. Different since same as it is G3, G2, G1, G naught. This is the input. Here first B3, the same as it is what G3 will be B3. So what it happened? All the same number present in the G3 will comes in the B3. Okay, because there is no changes in that, right? Fine. When you're coming to this case, do the second one for B2. The result is do XOR of result with next immediate of the input value. Okay, be clear in that again. Do XOR of result with this one. This is the result of B2. And do XOR of result with the next G1. The result will be B1. Do XOR of B1 with the G0, the result will be B0. Okay, now do this operation. So 0 as it is 0, then do XOR of this one and this one, and 0. Do XOR of this one, 0. Do XOR of this one, 0. So it's looking somewhat a reverse direction, right? But when you come back to the normal, you have to do the cross correlations, right? Okay, so likewise you fill it. So second combination 0 comes, 0 with the 0 0, 0 with the 0 0, 0 with the 1 1. Come to this case, 0 with the 0 0, 0 with the, yeah, this is the first one, right? And do the first value, that means 0 0 1 0. So do 0 0 1 1. So the result will be 1 1. Okay, comparably that one will be easier. This will be maybe all values will be combination of zeros and ones. Maybe it's a little bit tough to do it, right? So that's what I'm written sidely and written over here. Come to the next one, 0 0 1 1. So 0 will comes. This will be 0. This will be 1. This will be 0. So what is the combination? 0 0 1 0. Then come to this case, 0 1 double 0. So what it happened? 0 1 1 1. So 0 triple 1. Then come to next one, 0 1 0 1, right? So this is 0 1 1 0. So 0 1 1 0, right? The same way for all the cases, right? So do it, no problem at all. 0 1 0 0. So 0 1 0 0. So just do a practice with all the numbers. What actually, okay, right? So this case is 0 and 0 with 1 1, 1 with 1 0, 1 with 0 with 1 1, and 1 will be there, 1 with 0. That means 0 triple 1, 0 1 0 1. That will return. And come to the next case, 1 triple 0, 1 0 0 0, right? 1 is 1, this is 1, this is 1, and this is 1, right? So all will be 1 for 8, okay? Then come to the next, 1 double 0 1. So 1 will 1, 1 1, and 0, 1 1 1 0. Then come to the next case. Hope you are following and writing. Okay. And 1010. Then 1 will comes. 10 will be 1. 110 0 0 0. So 1100. Then come to the next. 1011. So first will be 1 and this is 1 and 0 and 1. So 1101. Right. The next combinations 1 double 1 double 0, right? So 1 is like a mobile phone number. 11000. So 1000. And come to the next one. 01. So this is 1 and this is 0 and 1. So 1001, right? Only two more combination. Please follow it. 1011. So 1011, right? And the last 1111. So what it happened is this is 1010. So 10110. So this is a complete gray to binary. Okay, so previously we seen binary to gray, now gray to binary. So how to find the circuit? So with the help of K-map. The K-map, so first you should write it with G3. If you want to find B3, so you just write it F of G3 comma G2 comma G1 comma and G0 is equal to sum of product of wherever 1 is present. Just write the min terms number 8 comma 9 comma 10 comma 11 comma 12 comma 13 comma 14 and 15, right? So you already know that when you substitute in the K map, the result will comes as a what? G3, because here going to use previously B3, B2, B1. So same as it is for the first one. When you're going to the second case, that should come 1 1 1 1 1 1 1 1. So 8 1 will come. So 4 5 6 7 8 9 10 11. So if you're moving to that, you just look on it. What happened? Very easiest way if you're finding it. This is 4 5 6 7 8 9 10 11. So this is 1 and this is 1. So what is a common term in this? What is a common term? Among these two cases, you may get it as B3. That means G3 exclusive of G2. So I have a more practice in that. Directly I'm written it without substituting in the K map and directly find it. So what you are going to do is, so take this number and find it. Then take this number and find it. And take this number, find it. So finally what you are going to get is the circuit completely made with the help of only XOR gate, not by the other gates and all. Okay, so what I want to convey in this is, what I'm trying to say is, so when you're going to practice binary representations or any type of conversion, first should be preferably you just go with an codes, binary codes, and weighted code, non-weighted code practically. And in that weighted binary code 8421, what is the procedure, and followed by 5421, 2421. So if you are having a good practice in the number, yeah, you don't need to worry about this. Otherwise, if any one of zeros and ones will be changed, the complete circuit will be changed, and you are not able to put in the K map, and you are not able to find in a Boolean expression. If Boolean expression not able to find it, you are not able to put logic gate. So the outcome will not come, right? So the best practice is, first you should know about Boolean expression, min terms, max terms, sum of product, product of sum, canonical form, standard form, followed by the truth table of each and every logic gates. And after that, when you're taking it as a practice, first you should write in a decimal number in the end. Then only the came up will be easier. Otherwise, this is 1. Can directly tell me what is the number for this equivalent decimal? If you have in a practice, you can tell. I can easily tell it, that is 7, right? So if you don't have in a practice, again you just this power, this power, this power, and finally some of the value will be is equal to somewhat different. So just do a practice in that and take it clearly. Then only you can able to understand in that, right? So I hope it's clear to you. If you have any queries, you just put in the comments, and I will explain you in better manner. Okay, so hope the further sessions will for another topic. will meet you. So if you have any queries in that, you contact us. Always welcome for any clearing in that. So hope this help you for the minimum interest rate comes in the digital electronics to learn about code conversions, and not only the code conversions, the digital will be is easier looking when my explanation will be fulfilled to you. Okay, thank you.